All right, so I'm going to be presenting the solution to some problems that I find would be really interesting from the general problem set of the math code. Uh, so yeah, I'll post solutions and answers to some of the problems that I haven't covered here, especially the proof-based ones. Um, I'll post like a PDF, photo, or whatever, but I won't be covering those in this video. Also, sorry for my monotone voice. So I got kind of sick. So yeah, here we go. Um, so this is problem two from the computational section, and it wants us to find this thing, this radical without a calculator. Um, so yeah, like what's the strat here? Well, preferably we want to get to a place where um all we're left is, taking the square root of a perfect square. Um, if we could somehow manipulate this um, into that form, that would be really great for us. So we're gonna try. We're gonna try. Um, First of all, what do we have here? 50 times 51 times 52 times 53. That looks pretty, tempting. So let's just, right, they all have 50 in it. They're very close to 50. So let's just try, um, manipulating with 50 here. What do I mean by that? Like, for example, like set x to 50. Um, what do you get? What do you get? This radical just becomes 1 plus x plus, x squared. Not x squared. X times x plus 1 times x plus 2 times x plus 3, right? Because each of these are corresponding to the numbers. Just remember we set x to 50. And here it doesn't look like we have a lot to do. I mean, for one thing, like if we multiply this way and this way, just the quadratics, they don't seem very favorable to us. So, a key thing to notice when you're on this step is to really think about how you could get your factors to look more alike. So, what do I mean by this? Well, let's just multiply x by x plus 3 and x plus 1 by x plus 2, right? Instead of just multiplying here and here in the normal way. What do we get there? Um, well, we end up with 1 plus x squared plus 3x multiplied by x squared plus 3x plus 2. So notice, notice x squared plus 3x is in both factors. So actually, you know, lets us, well, it actually tempts us to set, like, a new variable equal to x squared plus 3x. So what does that give us when we have the new variable? Well, it's just 1 plus y times y plus 2, because we have the 2 here. Now, quick simplification, you just get y squared plus 2y plus 1. And guess what? That is a that is the square of a monomial y plus 1. And well, uh, what you end up with is just y plus 1. Um, back substituting, we get y plus 1 is x squared plus 3x plus 1. And then finally, we set x to 50. So actually, it's just 50 squared plus 150 plus 1, which is, let's see, 2500 plus 151, which gives us 2651 as our final answer. And we're done.